All right, so page, what is it, 213? Let's read over that first one. So, badminton tournament, right? You guys kind of familiar with how tournaments work?
No, I know badminton.
Well, every round of the tournament, what proportion of the teams gets eliminated? Half, right? Every time? Isn't that what's going on here?
Yeah.
Right? What's half as a percent, guys?
0.5.
50%, right, but 0.5, yeah, okay. So that player's eliminated. So is there a starting amount? Okay. And would you say this is growth or decay?
Okay.
Yeah.
Number 1.
No, it's number 3.
Well, let's figure that out.
It's,
Number 3.
oh, wait, no, it is 1. Oh.
So we have an initial number of players. Whoops, I was doing that. 64 of them, right? 50% of them, 0.5, right? So your R here is 0.5, the decay rate, right? Every round. And they want to know how many are left after. Well, they don't want to know. They want the equation for 3 rounds. So which choice will it be? It's got to be choice 1, right? This is your 1 minus R. Initial value starting with 64. And you do that 3 times for the 3rd round. Okay, so choice 1. On to number 2. You should start to get, kind of repetitive, I think, for a while. By the way, a motorcycle, any kind of vehicle, you guys understand that after you purchase this, say, a new vehicle, it depreciates. You own it. You know what that means? The value goes down, right? Because you're driving it, you put miles on it, riding hard, putting it away wet.
This answer is number 1. I know.
Well, it's 12,000 times 0.75 to the T. Is that growth or decay? Why is it decay? Because the B is between 0 and 1, right?
I think it's number 2.
So what does the 12,000 mean in the formula? Yeah, right. That's the initial value of the motorcycle, right? So which choice?
It's 1.
It's 1? That's the purchase price, right? That's when you started. So it can't be 1.
It's decreasing.
Well, let's look at the other ones. Is it decreasing by 75% each year?
Yeah.
No, it's not. This is, it's remember, this is what remains is 75%.
So it's decreasing at
25, right? So the decay rate is 25.25, right?
so there's more. And it's 2.
Motorcycles value is decreasing at a rate of 0.25%. It's 25%. See, they kind of fooled you with that one a little, right? It's either 0.2, it's either going to be called 0.25 or 25%. They kind of combined them there, right? So what's the answer? Choice 2. That's the initial value. That's the A up here. On to number 3. The population one. City.
Why does it say up 17? Like,
Uh,
17.
Where?
The exponent, it says 1.0005, and then out of the thing it says 17.
To the 7t. Why does it say that? Why not?
But isn't it?
That's the formula. we may need to recall some of our exponent rules. Yeah? Remember, like, when you multiply bases, what do you do with the exponents? Add them. If you do a power to a power, what do you do with the exponents? Multiply them, right? So they're asking which ones would be equivalent. So what it looks like they're asking you to kind of mess around with this thing here with your properties of exponents. You see the 7 times t up there? That means the exponents were what? Added or multiplied? Multiplied, which means it came from what? Power to a power, right? So think about that for a minute. We could rewrite this as 3810, right? Times what? 1.00, how many zeros? 05, what? Notice I left the little space.
Put the 7 in, or the.
I can put the 7 here. See, there's my power to a power, right? We're just going backwards for the exponent properties, yeah? Right? Okay, because I would then, by properties of exponents, be able to take this and rewrite it like that up there, right? I'm just going backwards. All right, so, well, none of those quite look like that, do they? So I must have done something. Maybe some sort of calculation that you could do right now on your calculator. Yes, you do. Some kind of calculation that will end up matching that. Is there anything in what I wrote there that you could rewrite by putting it in your calculator? Nothing? Multiply by 7? Yeah, multiplying by 7. You mean a 7th power? Oh, why don't you try that? You guys hear what she said? I can't believe you're missing it.
Yeah, multiply by 7.
No, we're not multiplying by 7. The 7th power. Yeah. Try that, see what you get. See if it matches anything in the...
Yeah, no.
Doesn't match anything?
No, it says 3823.
3823. What are you putting to the 7th power?
That, the 1.0005.
Where'd you get the 3823 from? What?
1.00350525.
Oh, so it's 3810 times 1.0035 approximately, right? To the T. I guess hung up on that 4 that comes afterwards. Wouldn't that round to 35? Right, you understand that, Abner? We've done one like this before. So we just did the properties of exponents from this thing and worked backwards. Do you understand how we got from here to this? Right? Power to a power, we just went like back a step. We'd normally be going the other way, right? So it's choice 2, yeah? Then all you had to do, right, once you did that, then you just put that thing in your calculator and see what comes out as that, right? And there it is, choice 2. And yeah, you had some more digits, 0.0354, whatever, but look what it said. Yeah, so they rounded it. Okay. Moving on. This one should be pretty straightforward, I think. Nice to have parents like this.
The mom does it.
Yeah. His father did what? What did his father do for him?
Invested $5,000 in an account with a 1.3.
And when did he make this investment?
He was born.
The day he was born. Okay? Can you write a function for this?
Yeah, A of
So what's the starting amount? Okay. What's the rate? 0.012. Right? Is this going to be a 1 plus R or 1 minus R situation? Right? Because remember, huh? I shouldn't use A, I guess. I'll just say like B for balance equals starting amount times 1 plus R to the T, right? Because it's growth. Oh, right, you don't want the money to decay. So what's our formula?
1,000
A of T equals,
5,000 1
Plus 0.02
that's it,
to the
to the T power, right? I mean, yeah, if you do the 1 plus thing, then you gotta rewrite it again like that. That's fine.
5,060.
Okay? All right, so what about the follow-up? What do you mean 5,060? Well, what do they want to know? It sounds like you don't really want, you haven't really read, everybody read this follow-up here. There's a whole sentence there. I keep hearing the number 17. That's in the sentence, yeah, but read it.
after how much more money have in 32.
Okay, so we have to figure out how much money he has when he's what?
30.
And figure out how much money he has when he's,
17
and then subtract them to see how much more. So how about the A, got a formula of 32, right? Equals what? 5,000 to the what power? Okay? Go ahead. Put it in your calculator. What do you got?
700, or no, 7,353. There's like a bunch of like.
It's money, right? So how many of those bunch of things are you gonna lose? 2, money, right? What is it, 7,000 what?
7,353. 96.
90 what?
96.
No.
Oh,
Well, you guys can't round. What's
97.
97?
I don't know what I wrote.
If the number after is 5 or higher, you round it up. Under 5. All right, so you get that, right? So now you got to find the amount at 17. Everybody do that now. Run your calculator. We need a fancy one.
Okay.
6,124.5.
So $6,124.05. Sure it's 05 and not 06 or 04? What was that? Huh? Okay. Just rounding. You guys got to round. They'll crush you on the regions for roundings.
I don't think.
Are we done?
No.
What do we have to do? So we just do 7,323.97 minus 124.05. What do we get?
1,196.
0.92. You probably left You probably left all the decimals in your calculator, didn't you? And then subtracted. All right, have we finished this problem? Is it exactly right? No, it's not. What are we missing here? What, say it again? You guys see this? What I tell you, I just got done telling you, right? They crush you for rounding. So how much will it be? It'll be $1,200 more. Right? So you always make note of what they want you to round to. Okay? Always. Because you would have lost points for that. Even though that's the correct number, right? They told you to the nearest dollar, so you get points taken off for that. All right. Bacteria. Exponential function. Okay, is this growth or decay?
Okay.
Because that's between 0 and 1. That's number 2.
I got number 3.
Number 3
Or number 4.
represents the population. What is the rate of decay? Listen, guys, remember,
That's what's left.
that is what remains. 98% remains, right? That's not the decay rate. That means the decay rate is what? 2%, right? Or another way you could do this, right? Isn't this 1 minus r? You could do this. 1 minus r equals 0.98, right? Subtract 1 from both sides. You get negative r equals negative 0.02. So r equals what? 0.02, which is 2%. It's another way you can do it, right? Algebraically. You get where I did the 1 minus r, right? Because that's 1 minus r. Find r. All right, let's go to the next page. Is that Hannah? Mumbling. Say, hey, some more decay. You were going to need to think about properties of exponents for this one, guys. Why? What would make you... Well, let's give her a chance to read it. It's 2 materials, right? For decaying. That's what radioactive material does. There's no bananas are radioactive.
No, I don't even know that we need.
Bananas, it's a yellow long fruit.
Oh, radioactive.
Yeah, it gives off
It's
it,
pretty, yo.
particles. It kind of vaporizes.
Bananas are a fruit.
Yes.
I thought they were berries.
Actually, they are berries.
Yeah, they are. Yeah, but fruit or berries are technically fruit.
Anyway, they're radioactive. You know,
Berries are
potassium.
You've been reporting. You got reported.
It's true.
No, you've been reporting. It just doesn't show up sometimes.
Yeah, sometimes I don't know why it does that.
We're talking about bananas.
Anyway, so they want to know on which day we'll have the same amount of material. Well, did they both start with the same amount of material? Though they didn't?
Yeah, they did. 1,000.
1,000, whatever, grams or something, who knows, right?
But they have a different price for that.
They do, but look at this one. So I wonder, there's a couple ways we could approach this, right? Properties of X, but we just did that, right? So know how to do this, right? You get, that's 2 times T. That means it came from what? Power to a power, didn't it? Right? So let's take A. So what they want to know is when the amount of A equals the amount of T. So we want to know when A of T equals B of T, right? Well, let's see if we can mess around with this A of T thing here, the way we did. So let's take our A of T. We got 1,000 times 0.5. I can square that in here and on the outside put a what? T, because that's my power to a power. That would become 0.5 to the 2t. Okay, so everyone do something on your calculator now.
It's the same.
Is it?
Every day.
It's the same equation. So it's
Well, what is it? This becomes 1,000 times what?
0.25.
Times 0.5 squared is 0.25 to the t. Hey, isn't that b of t? So if their decay equations are the same, then when will they have the same amount of material? All the time, right? From start to finish. Yes, you did. But I wanted you to know why for sure. Okay? You guys you all understand how to manipulate something like that with properties of exponents. It's going the other way, right? That's a power to a power. Okay? All right, moving on to number 7. Everybody reading it? What'd she buy a doll for?
Worth $550.
I can't even imagine, but anyway. And what happens to the doll's value?
It increases by 0.025.
2.5%, right? 0.025. So, everybody write an equation. What letters are we using?
T and B.
So we'll start out by writing what?
V of T.
V of t. So did you say V to that's, you just said that. No, it's just, my point when I do this kind of thing with kids is that math is a language of precision, right? That you can't just say something mathematically and then say, well, you know what I mean, right? We're not texting, okay? We're not DMing.
ABCDFG8.
Nope, I don't.
I know, because
Why does it do this to me? Well, V of t is going to equal what, everybody? 450.
Times.
Well, where do we get that? What, times 0.025?
Yeah.
So it's going to decay? Yeah, 1 plus, right? 1 plus 0.025. What? To, oh, okay, T, like that?
No.
Please.
Power.
Yes,
To the T.
speak precisely.
T.
Well, let's simplify that. 450, whoops,
B.
B of G equals 450.
1.025.
to the T power, there we go. All right, hopefully you're getting comfortable writing. It's either 1 plus R if it's growth, 1 minus R. Don't forget the 1. Okay? All right. So, assuming that the appreciation rate remains the same, will the doll's value be doubled in 20 years? What the heck do they mean? Doubled.
Will it double in price?
Yeah.
Will the value of price double?
Well, it'd be nice to know a number for when it doubles. Because then we can, if we knew what doubling meant, we could put 20 in our little equation there and see if it reaches it.
Doubling means multiply by 2.
Okay. What are you waiting on? What value are we looking? What value, huh?
37. No, 0.38. Why did I cut eggs?
Okay, is that doubled? Is it?
I'm not right.
900.
Well, I need to know what double means.
900.
Oh, how do you know it's 900?
Because that's what 450 dollars.
450, if we double it, we need to get what? We need to see if it's $900 in 20 years. Okay? So-
It's not double, so it's no.
So how do you know? You said you did V of 20, right?
Yeah, and then I did 450 times the 1.5.
1 point what now? Thank you.
That's why I did it, and I got 700 something, and you guys told me.
Tell me what, 700 what?
737.38.
30, are you sure about the 8?
Yeah,
Or 7.
it's 38.
I said 38.
Are we done?
Sure. No, because
Did we answer the question? We did not.
No, it won't be doubled in 20 years because
You said it would be earlier.
I didn't say that.
You did.
No, I didn't. The answer is no. It would have needed to get to $900 or more to double. Okay? Moving on. Ah, it's like the motorcycle one.
it's a car, and
Yep.
then it's a motorcycle.
It's like the motorcycle problem. Okay, well, what's our function, everybody? V of t
Equals 25,000 y minus 0.185.
1 minus what?
0.185.
18.5.
0.185, yes, to the t, but let's simplify that, can we?
Yeah, it could be a times 0.815.
Is that what it comes to? 0.815 to the t. Right? That's the 1 minus because it's decay, right? All right.
But you said you.
So
No,
No,
that's
no.
only if it's increased.
there's, I thought I wrote, never mind. It's, oh, darn it. It's either gonna be, look, growth is A times 1 plus R to the T. Decay is A times 1 minus R to the T. Thanks from the notes. And since it's depreciating, okay, so it's 1 minus, right? All right, so do the follow-up, everybody. So what do we have to do? Oh, we gotta, yeah. So we have to find two things, don't we?
Yeah, that's fine.
it's 3 and 4, right?
I did 3.
It doesn't matter. Then V of 3, 25,000, that's 0.815 to the 3. Appreciate your 3 or your 4. Well, what's the value at year 4?
11,029.89.
I like it.
Who do you want?
87.
87.
I'm making this up.
Was that year 4 or 3? Yeah, it was 4. What's the value at year 3? Anybody?
13,533.
13,533 and 58 cents. Have we answered the question?
Yeah.
No, we have not. What is the question?
What's the deficit?
No.
Deficit.
Depreciation.
Depreciate is a verb, so you don't just say, what's the depreciate?
Wait, that was the word.
Depreciate
Depreciate.
is a real word, yes.
It sounds like.
So what do we do?
Somebody like does that and then it ends in.
What do we do to answer this, kids? Huh? Run what?
Subtract
I have to subtract them, right? Did anybody actually read the question?
No.
Because they said, what do you do? And no one's done, right? How much will it depreciate from year 3 to 4? So we have to subtract these values, right? So 13,533.58 minus 11,029.87. What do we get? You guys agree with that? And circle your final answer, right? Any of these? No? We're getting stuck. Tell me where you're stuck, Ann. Well, they're all about the same. They're different problems, but they're all about the same, right? It's either going to be growth or decay. 1 plus R or 1 minus R, right? They have you write a formula, and they have you use the formula to plug some value in. Let's try number 9. Rabbits. What do they like to multiply? Everybody's reading number 9. Nope, it's rabbits. Just like when you read, you see the word rabbits right there. So what do the 20 and the 1.014 represent?
20 is the starting point.
Hold on. In the context of the problem.
It's the starting point of the rabbit.
Yes, it's the initial. So we can say the initial population of rabbits, something like that, of rabbits, is how many? Is 20, or you could say they start with 20 rabbits and be less words, I guess, right? And what is the 1.014 mean?
How much you're losing?
Losing?
It's increasing by 1.4%.
And there we go. And it increases ES by how much?
1.4%.
How often? Per day. See, context of the problem, right? You can't just say 20 is the starting amount. Because that's generic for any particular rate. All right, so. Yes, average rate of change. Remember how to do that? No? F of B minus F of A over B minus A. Remember that?
Yeah.
So here instead of F, it's P, right? So what's our second input here?
50.
No. 100 F or P of 100 minus P of 50 over look at this. Over what? No. We're doing average rate of change. It's like this. Over what, guys?
Over 20 minus 1.4. Where else are we the number?
1.01.
You see this?
Yeah, I'm trying to B minus A.
Oh, 100 minus
100 minus 50. Right?
It's the same thing. It's the same thing.
It's 20 and 0.1.
No, I meant like the top and bottom numbers are the same.
Well, not the same, right? But that's, so these are the inputs, right? Remember, it's the ending output minus starting output over ending input minus starting input.
different numbers, not with
Yeah,
this.
but 50 over 50 was 1.
You have to multiply by
That's
one.
not 50, that's P of 50.
What is that? Oh, I know how to do this. Not really, but I'm gonna tell you I do.
Seriously?
I remember this. I just,
Put 100 in here. What do you get? Use your calculator.
I did for 50 and I got like 40 something.
Uh-huh. Okay.
I got
How about-
80.32.
80.3203. Look, they want to the nearest tenth, right? At the final answer.
Yeah.
So whatever they want the final answer to, you always work out like 3 more decimals than what they want the final one. Okay? With me? Minus what? Not 50.
No.
P of 50. What's P of 50?
It's like 20.
Tell me what it's like. You have a calculator. Tell me what it
I
is.
just had it, but I did it. What's the alphabet number?
Can anybody else just push that in your, so, wait, hold on, you guys are doing, somebody else, put that in your calculator and tell me what P of 50 is, somebody other than those two. Do P of 50, what is it? 40.080, yeah. Okay, over what?
50.
100 minus 50 is 50. Now, what does that give you?
40.2403 over 50.
Which is what? Okay, to the nearest tenth. Point to the nearest tenth. 8, what? What's the units? Rabbits.
Per day.
There we go. Per day. Average rate of change, guys. 0.8. I know, that's an average rate of change. It doesn't mean, right? Okay.